if we want to do probabilistic programming. And simulations. A lot of scientific and enterprise applications require simulation. Now it's very interesting and maybe too popular approach which you could find almost everywhere. For example, in Ukraine, Nibulon have created digital twins, and at this and here, when the simulation and digital twins, fully digital simulated twin of some process or some stuff or some feature, twins of some managed goods. Simulation you can find in computer gaming, and I have the probably most interesting question, which I want to ask almost everybody who try to reset, to change their mark during our exam. The question is, why JS software developer should learn probability theory? We will talk about a little bit later. And one thing which I hope we will talk about it maybe 1 or 2 years after this course is software and data security. Uh, Probability and combinatoric is a core function of software security. Cryptography. So today we will talk about probabilistic programming. And we have a little one more question, which now still is unanswered here. Question is, why JavaScript software developers should learn probability theory? And now I want to have a little conversation with you. You can use chat or you can use voice, anything. Question is, why JavaScript software developers should learn probability theory? I have a harder question, why front-end developers should learn probability theory. But let's stop at JavaScript developer should learn probability theory. So when we talk about JavaScript, when we talk about probability theory, how could we understand? How could we, maybe somebody of you have some ideas why JavaScript software developer still need probability theory? This question will be, I will ask during my exam. I will ask your specialization. For example, if you're a Python developer, you can say that you want to create some data science applications. So if you want to have data science job, if you want to have this artificial intelligence machine learning, you should know probability theory. But what if you just front-end developer? Why should you learn probability theory? What kind of decision would you make to receive results, to estimate probability of these results? So that's a question. Please try to answer in chat or using your voice, if you are still here and if you can hear. By the way, while you are listening to me, please mark yourself on DL. Do not forget to mark attendance of the lecture at distant learning site. So, do you have any ideas about JavaScript, software developer, and probability theory? Okay.
Actually, if we're talking about
Yes.
just front end,
Yes.
I think that just for only front end, it's not really necessary. But if you're talking about all the JavaScript, so maybe
Front end and the back end, yes.
yeah. So maybe in some kind of maybe games or maybe casinos.
Have you ever heard about D3GS? Try to look at it, try to Google it. D3GS. And tell me something about it. Also, advertisement. If we want to talk about advertisement, yes, if we are talking about spending a lot of money on something, yes, if we talk about placing of the banner on the some place, I will show you one more keyword. I want from you to take a look into the keywords and say to me, what do you think about it? Think a little bit more. Try to Google these keywords, and the question is, and one more. So if you try to Google these keywords, if you try to make these things together, probably you will have more ideas why front-end JavaScript developers still require probability theory. 1 or 2 minutes, let's try to discuss it a little bit more, because we need discussion. It's very important for you to talk and to form your thoughts correctly. So if you have ideas, you can write it into the chat. You can talk it using your mic, using your voice. So please, any ideas? My hints is almost the answers. If you want to try, just check web statistics on your front page, on your front end. Try to see D3GS, and you will see why do you really need probability theory. So, any thoughts, any messages, any words? Let's try to make pause for 30 seconds, and then I will describe my thoughts on this direction. Or maybe somebody would tell me what does...
Maybe some kind
Yes.
of prediction of statistics, so we know maybe if we want to know the average amount of users on the site and predict it based on some I don't know, some
user actions. Some user actions. Yes. And Anastasia?
maybe not only user actions, but maybe our new updates or something like that.
Yes, Anastasia Naboka.
Yeah, so probability theory helps interrupt web statistics accurately. For example, understanding if higher click rates are due to real user interests or just random variations. But moreover, you also wrote about D3GS, and I googled some information about it. So it helps to visualize data, and probability allows developers to create charts that clearly represent uncertainty, trends, and user behavior patterns. So it's in fact, it's what is probability statistics used for. Also, in it used in advertisement placement. Probability helps analyze which position or layout are most likely to attract attention and clicks. And also, I looked through some information about hotspots on a web page. It shows where users are mostly likely to interact based on probabilistic heat maps.
Yes, heat maps,
Yeah.
probabilistic heat maps for advertisement. It's must have. It's things which differs just junior software developer which making things which he have been
Yes, so after all, probability helps developers to analyze where it is better to place ads and how to design data drivens effectively and user friendly as well.
Yes. Okay. So we are stopping to discuss this chart related with distributions and probability theory, why we need it. And we are switching to our topic of our lection, this lection, probabilistic programming. And the key problem and the key point here, it's the distributions. So we are talking about distributions the whole previous lecture. Could anybody say me what is distribution? You can use anything, internet, ChatGPT, let's discuss it. What is distribution? Because I need that you understand my point. Why understanding of distribution is so important. What is distribution? Plus example. Anastasia and Evgen already answered. So maybe I will ask somebody else, or maybe somebody want to say something about distributions, because we will move forward. And one of the reasons why I want to talk about distributions, I will share a little bit different screen now. If we talk about Python development, we should talk about SciPy. Let me change about SciPy. Stanislav, yes, good. Distribution tell you how likely different outcomes are in random process. A map of probabilities across all possible results. Yes, that's it. That's like previous time I draw to you table of probabilities for each outcome. So some outcomes are more possible, some outcomes are less possible. So that's it. Okay. So today we will try to simulate some distributions, and we will do it using Python, and then we will try to formulate a task which will be solved using distributions we just learned. For current code, I will use NumPy, its library. Let me open its library related with numerical computations in Python. SciPy library which allows to us scientific functions, and plotting library. If we take a look into my first cell with code, let me start it. By the way, let me share this notebook for you, so to make it a little bit easier to work. And if you never work with Colaboratory before, it's excellent way to make calculations in the cloud on the servers provided by Google, because on this service we also can use GPU and TPU. I have GPU enabled only T4, but sometimes it's A100 and L4, but I have only GPT-4. By the way, it's so fun translated, but it's what we have now. So try to use Colab. I will share it with you. And you can open this link. It's shared for National University of Radio Electronic. And you can see this simple code. So I imported norm from SciPy stats, and if we go to the main SciPy namespace, we receive probably the most usual problem which we can see as software developers during our work. Yes, we see some library, but we should understand what kind of function we want to use to solve some problem. And here is documentation, and we should understand what cluster means, clustering functionality. So it's better for you to understand what does it clusters. Constants, data sets, and so on. Interpolation, reading, writing. But we on the course related with probability theory and statistics. So our point is here. And what we can see here, we can see this, a large number of probability distributions. What probability distributions? One more link. It's excellent chart. It's excellent chart which shows to you families of probability. For example, if we select normal, you will, if you click on it, you will see a little cheat sheet of this distribution. And if we hover the mouse over the normal, you can see different distributions related with it, like a standard, normal, non-central, chi-square, and so on. And this very nice probability map created in VM Edu in this university. Let's take a look. What university? William and Mary University. Excellent distribution map. And we can see how many different distributions we are here. And it's not all the distribution, but the most important distributions you can see at left side, discrete and continuous. And now you should remember my previous lecture, and just to remember discrete and continuous distributions. And if you talk about discrete, we can see Bernoulli, logarithm. It's interesting. There is uniform. They do not show us uniform. I think uniform, you can find it here. Uniform distributions. And rectangle distribution, and so on. So it's excellent place to learn different kinds of distributions, because if you click, you will see definition and formula equation of probability density function here. Sometimes you can see also usage, but oh yes, you can see the usage. Let me increase usage of this distribution for modeling adult height, newborn baby weight, ball bearing diameters, etc. So excellent place to take a look into different kinds of distributions. And now, if we return to SciPy stats, we can see that we have distributions, summary and frequency statistics. We already have had lecture about it. Correlation functions and statistical tests. We will have lecture about it a little bit later. Masked statistic, kernel density estimation, quasi-Monte Carlo functionality. I'm not sure that it will be covered by our course, because I think that this you will learn on courses related with data science, or maybe courses related with high levels of math. But in our course, and you could see a lot of different distributions in one row, and continuous distributions, multivariate distributions, and discrete distributions. And see the difference. They have a re-continuous and a re-discrete class, so it's a lot of difference. And you see word univariate, and you have seen multivariate distributions. What means univariate? There is only one variable which is random, univariate, and multivariate when there is more than one variable which could be random. So multivariate and univariate distributions, you could see it here. And returning to our little test, we want to generate different random sets which could be used for modeling later. On the next lecture, I think that we will talk about a great theorem of statistics, about the law of large numbers, about Chebyshev theorem, and so on. And when we talk about it, I want to model some examples to show you how it works if we try to apply it to reality, or if we try to apply it to computational experiment. So that's it. That's the way to model some random variables and some random process. So first, here is norm RVS. Let's assume that I don't know what is RVS. So I go here, normal, normal, normal. Normal distributions. Let me try to find it. Normal. Normal distribution. We could see the probability density function, which I have written to you in previous lecture. And we understand from this function that we have two parameters. First is mu, and second is sigma. Mu and sigma. It's parameters of these distributions. We have argument x, we have result f from x, we have constant p, and we have two parameters, mu and sigma. We can change it, and we can change it, mu in these bounds and sigma in these bounds. And we have been used RVS method. RVS method. Let me get it. It's continuous. And we see that RVS method should be overwritten by subclass, and this method generate random variables with parameters, mean value and standard deviation, and size of this. And we have generated one variable. If we take a look into this variable, we will see which numbers have appears. Let's generate one more random variables with little bit different values of mean, but with same value of standard def, and one more random variable, uniform. Uniform distribution is also continuous distribution. It's also continuous distribution. And then we could do some tests on these random sets. We can show first 10 values of first and second variables, and we can plot this data and what we can see. If I run it one more time, we will see that this diagram have slightly changed, but we could see something that repeated each time we regenerate data. Returning to this cell, what we are doing, we are plotting histogram. We are plotting histogram with first 700 of these points. I can take more data, but it will take a little bit longer to draw it, for example. And I even can take everything here. And we will see a much more smooth diagram. And what things I want to show you, what parameters I want to take your attention to. Take a look at the 0. 0 is on the center, at the center of this generated random variable which has normal distributions. What does it mean? That these values will appear much more often than, for example, this one, than this one on values. And the second, you can see standard deviation 5. If I set and take a look here, 15 and 15, here is what we are talking about when we could find most of numbers. We have not talked, I have not tell you anything about 3 sigma rule. We will talk about it a little bit later. But what I want to show you, if I make standard deviation here, for example, 100, you will see the difference. Random 1, let's check random 1. Do you see it increased? And if we run it again, it looks that the picture is the same, but the scale here is different drastically. because we increased standard deviation. And now if we try to draw both variables on one chart, we will see that, and now you can see it here by these numbers. These numbers decreased, really decreased, because we have more flat surface here. In this scale, it's the same, but we have a really more flat surface here. So let me return. Do you remember numbers 0.004 and these numbers? But if we try to set 5 again, what we will see? You see, it should be really higher than before. And this distance really smaller than before. But what is this distance? It's like 3 sigma. It's a 15. It's really 15, so 3 sigma. So we'll talk about a little bit later when we talk about properties of normal distribution. Now, today I want to talk about distribution and usage of this distribution over the time to solve some problems. Take a look into next plot. We can see random number 2. Yes, it's the first 700. Let's make it the same like in previous. And what we could see that probability of appearing these variables here are really different from probabilities of appearing here. And that's what is distribution. And histogram, it's just a way of statistically to confirm distribution properties. If we take a look here, let me find it. It's RVS methods on array continuous and the child class here. Do you have object-oriented programming? Do you understand what I'm talking about when I say child class? I hope so. And if we take a look into uniform distribution, let me find it. Uniform distribution. We will see this kind of formula from A to B, and we have parameterization A and B. So when I call it, and let's say 0, 5, random norm minus 1 plus 2, let's say maybe minus 15 and no. Yes. Plus 15 and A and B. And B, and let's name it A, and let's name it B. Let's make these names logical this time. And let's take a look. B minus A from A to B. Yes, this. We need to go to previous class, RVS. RV continues. Location, scale, and size. Let me see the difference. And let's see the difference. And we should take 13 to receive something which looks like from minus 15 to plus 15. And that will be from 15 to 15. And we will see the difference in the shape of probability and difference in the size of probability. Because here the probability of appearing some value is 0.035, but here we have some probability of some values is up to 0.08. And now I have a question to auditory. Please, looking into these two charts, give me example of normally distribution value from any real example, and give me example of uniform distribution value from any example from real life. You can use this map if you want, which I have, which link I have already sent into the chat, and let me send it one more time. Or ChatGPT, or any you want to do. Real example from uniform and real example for the normal distribution. And write it into the chat, please. I'm waiting for your answers.
So we need to provide the real world examples of graphics or what?
Real world example of random variable, not graphics. It's like human height, average height, and so on. Yes, Vitaly, it's correct. And same for the uniform. We need same example for the uniform distribution. For the uniform distribution. When we want to model something, we should understand what we want to model and how to model, because modeling all the height using uniform distribution will be totally incorrect, because probability of height of 2 meters of 20 centimeters will be equal to probability of height of meter and 75 centimeters. It's totally incorrect in model. But if you will use normal distribution, your model will be close to reality in this case. And the only and the only what you need to do, you need to know the distribution of some modeled variable. For normal and for uniform. For normal and for uniform. Oh, it's excellent example with bus, but I think that bus arriving, it's really could be contested, could be question under the questions. Is it really uniform? Discrete uniform, it's probably yes. Rolling of a single fair six-sided dice. Yes, I agree with you. If we take a dices, if we flip a coin, if we do anything, maybe if you run the ball on roulette, you will receive the same uniform distribution. So let's return to our lecture. Randomly, one more answer. Uniform randomly show of one of several ads. Stanislav, could you, Anastasia, could you please a little bit describe about ads showing? Because it's not so easy and not so clear as I expect.
Oh, I meant firstly we talked about development. So I meant like when we are developing and having different banners, for example, and one of them shows randomly, like just different variants.
It's interesting. Why I'm talking about it? It's interesting. It's interesting topic because I have some experience in a really long ago past with development of such system which already not working and disappeared in the past. But the most important question was how to show banners if somebody want to buy 1,000 of showing and somebody want to buy 10 showings on the banner place, on the ads placement. How do you think? Should it be uniform or maybe something little bit different if we have different numbers of salad showing of at your ad place?
In this case, it will be not uniform because the chances must be equal.
Exactly. And if we talk about reality, it's not uniform. That's why I think that randomly show of one of several ads, it's not uniform. Usually, probably it could be any kind of distribution depending of what amount of money already paid, depending on only on one, what amount of money already paid. And we couldn't model it with uniform. Roll a fair die, yes, I agree. Lottery numbers, yes, probably agree, not always, but probably agree. Random seat assignment, probably agree, it's combinatoric, yes. Spin a fair roulette wheel, yes, agree, really agree. Just a second, please. Just a second, please. So let's move further to the next point of our lecture. Let's try to think that we have this kind of question. We have count of text and messages between two members during the time. Sometimes they texted 11 times, some days they texted about 770 times. So the question is, did the user's texting habits change over time? Looking into this chart. If we can say that this is small, maybe little bit easy and not realistic task, but I want to assure you that if we take data about words in TV shows or about words in tweets, in Facebook posts, or any source of media, and if we say the same question, did the user's name repeating changed over time? This question will be about real interest. This question usually appears during the elections. This question usually appears during important events and so on. So, the simple task. By the way, this task taken from the book which called Probability Software, Probability Programming and Bayesian Methods for Hackers. I will copy the name of the book here into the chat, and you could easily to find. I will give you a link also, and we will talk about the solution, and we will talk about how we could solve this problem. It's much more interesting. It's much more interesting because we want to use instruments which we have been already learned to solve this problem. So we have statistic about user texting habits, and we want to understand, did the user texting habits change over the time? So what is the idea? I want to ask, how could we solve this problem? I want to ask, how could we solve these problems? And usually, by the way, let's stop here, and I want you to use artificial intelligence, ChatGPT or Gemini or any other AI software. Try to copy this picture into the AI and ask equations. Did the user texting habits change it over the time? And let's try to understand what would he answer to you. It's really interesting, and I want to see output. Let's make a pause in my speech for maybe 1 minute to make this experiment on your side, and then let's try to discuss the results of this experiment. It will be really interesting, and then I will explain and discuss how could we solve it from my point of view. Two minutes. Somebody make it in AI chat text box if it allowed to copy images here. By the I need to show you the image. Yes. Here it is. Here is the image here. You can maybe it should not cut it. It's copied. I thought it's copied it. Oh, it's not very good. Let me try to. Maybe it will be better. Next will be better. Oh. Next really better. Next really better. Next image really better. Evgeny, I want to see you. Yes, they clearly change it. Brief analysis. Inconsistent volume. Around day 23. You see the if you see the answer, I receive something like this also of AI system. The most important question is do we really can prove it, and do we really can we believe it? And the answer really is good, and this answer could point us to realistic solution. But what is the question? Did the user text and habit change it over time? And how could we answer this question? What we want to receive from this task? We want to receive first, did habits change it? Yes and no. And second, when did this happens? And the correct way to solve this problem is to model. We take some amount of data, let's say 10, and create a model and then we are trying to apply this model to the next element. And on the next iteration, we add one more element to our model, rebuild it, relearn it, re-estimate parameters, and then we will take this data and check, are these data fit to modeled parameters of our distribution? Then we will add more data and again, and we will receive some point, maybe here, when our model, our some kind of average, maybe it's better to say central, some central parameter, central estimated parameter is changed. And applying this model, we could find exact point where it happens. If we apply model to the data, when estimated central parameter of the distribution have been changed. And it's not the only way to solve this task, but it's not bad way to make this task explain it. And usually we could model and explain this data, model and explain this data using probability theory. So what is the key idea here? The key idea here is that the data here are discrete, and I want to ask you, could somebody say me why the data on this diagram are discrete? Why we think that this data discrete? Please write it into the chat. Or maybe say from voice to be sure that somebody listen to me. Why is this data discrete? Why is this data discrete? Mykola? No, we do not need round. Because it's a count. Because it's a number. Yes, correct, Bogdan. Because it's a number of text messages. It can't be fractional. Exactly. It's what we are talking about. So the data is discrete. Okay. Second, what we should understand, how can we start to model this? We should understand a behavior. We should understand what kind of model should be used here. If you will ask me, is this a random process? I will answer, I think so. I think definitely yes, it's a random process because we do not know something. We do not know what caused the message. We do not know who is messaging. We don't know nothing. And we could not predict with 100 probability, with probability 1, what happens next. So it's random variable. Somebody will correct me and say it's a random process, and yes, he will be correct. But in our course, we are talking about random variable, and I describe a random variable to you. So it could be, this process could be modeled with random variable. Yes. We know it's discrete random variable. And there is a question, how could we model it? And in the thermoprobability theory, there is only one question which we should answer. The question is distribution. What kind of distribution here? What kind of distribution here is used? What kind of distribution here already used? And this is the K equation, because this equation is pretty easy to estimate. What kind of distribution? And the short answer, how to estimate distribution, is we should take a look into the nature of this process, and we will take the distribution which appropriate to model of this type of count data. And here is my advice to you. Try to ask artificial intelligence now, just for try, what is the best distribution to model number of messages in the phone, number of messages during the time. And let's try to understand their answer. What is the number of, what is the best distribution to model the number of messages? And why? Let's try to ask it. And then we will try to discuss this answer. And I want again to share with you something different window, some different window. I think this one. And you see this number of different distributions, and we can filter it. Binomial distribution, if we open it, we will take a look. Random variable has a binomial distribution, positive integer and real parameter. Number of successes of n mutually independent Bernoulli trials. So it's not our distribution. And Bernoulli, polar, negative hypergeometric, beta binomial, rectangular, discrete uniform, zip, zeta, and so on. It's not about, maybe let's take a look at it here. Polar distribution. It also looks not like our distribution. Does somebody has the answer about the distribution? Because I couldn't see it in the chat. Oh, I see it. I see it. Maybe not. Why the negative binomial is the best? Let's take a look into binomial. I'm not sure that binomial is the best. Mm-hmm. Let me share to you to discuss it. No. Take a look. First is negative binomial. Negative binomial distribution, a Pascal distribution, discrete probability distribution, number of fail-safe independent Bernoulli trials. What is Bernoulli trials? Random experiment with the two possible outcomes, success and failure. So this is not what we need. Negative binomial, it couldn't be applied to this kind of data. It should be applied to Bernoulli process. Bernoulli process that take only two values, canonically 0 and 1. I'm pretty sure that it could be used, but nope, not this time. Model with negative binomial distributions. Poisson. Allows the rate. So I think here, let me check. But I think here artificial intelligence couldn't be used easily only with some restriction. And let me show you article about it. Yes, you can see it. It's what we are talking about. Count variable. word frequency data. By the way, this article is pretty fresh. If you count the number of occurrences, we obtained a frequency distribution or a token distribution. And we can see observed frequency, expected frequency. The most basic probability distribution is very famous Poisson distribution. Yes, Poisson mixture K. And negative binomial distribution. And then they move to gamma distribution, text to text. And combining with other distribution with this complex procedure, yes, theoretically we can use okay, from this point, moving with negative binomial distribution, let's try to, let's stop and try to understand, do we have negative binomial? So if we take negative binomial distribution, I agree it could be used here, but with some modifications and restrictions. We could receive and model our text messaging. Like this. The same result we could obtain if we will use Poisson distribution. And here we have two hypotheses. Poisson distribution, classic for counts, and negative binomial distribution. AI proposed. During the next lecture, we will try to apply these distributions, apply these models to data and compare. Так, на сьогодні ми будемо завершувати. We will finish for today. Єдине, що я хочу додатково вам повідомити. Для студентів, які проходять курс Вільдау, будь ласка, пройдіть невеличке соціологічне опитування на запитання цієї онлайн-анкети не більше 10 хвилин для того, щоб зрозуміти, як проходить наш проект по Вільдау. І чекайте від мене повідомлень, я надішлю їх на курсі Вільдау, коли будуть проходити наші наступні заняття. Якщо є запитання, задавайте. Якщо запитань немає, можете від'єднуватися. Дякую за увагу.
Дякую, до побачення.
До побачення.
Дякуємо, до побачення.
Дякую.
До побачення.
Дякую, до побачення. Анонія.